Hemlock woolly adelgid is a very small aphid-like organism. It's native to East Asia. We believe that it was actually accidentally introduced with a live hemlock plant imported in 1911 in Richmond, Virginia. At that time, there were catalogs, and you could buy a hemlock tree that was maybe 6 or 7 feet tall, and it would be imported with roots and everything. But no one actually discovered this insect until many decades later in the 1950s, when people started to notice that there was insect damage on those trees. But it was not a really big deal because Richmond is kind of outside of the range of hemlock. It wasn't until the 1970s, 60 years after their initial introduction, that it actually started causing damage, when the insect started to expand its range into the Shenandoah Mountains, where hemlock is native, and started defoliating large thousands of hemlocks. Scientists use this term invasion pathway to describe the way in which an organism is transported from one part of the world to another. There are many different invasion pathways. I work with forest insects, and there are two dominant invasion pathways that we know are responsible for most insect and disease invasions. The one is the movement of wood, both the imports of logs, but more recently it's the imports of solid wood packaging material, things like crates or pallets. But the other invasion pathway historically is responsible for most species of insects and diseases being imported to at least the United States and many other parts of the world is importation of plants. Globalization of trade has exploded, and somewhere around 5 billion plants are imported to the US every year.
When we began the research at SESYNC, we were really focused on trying to better understand how to cost-effectively manage a very important invasive species pathway. Invasive species introduced through trade and movement of people and end up causing substantial ecological, economic damages when they're introduced in new systems.
When we started this project, I think many of us focused on the damages that are caused by insects that have been introduced with plant imports. As the project went on, I think we came, in all honesty, to appreciate sort of the other side of the equation, which is there are many benefits associated with plant imports in the United States and other countries. Not only people enjoying these plants, but also there's a large industry which markets these plants, and of course there are the producers overseas. It's a very complex problem.
We brought to the table scientists from various different disciplines. This included economists, entomologists, plant pathologists, ecologists. In addition, stakeholders and decision makers.
We didn't want to just have scientists analyzing data independent of the government agencies that would actually be using this information.
There was an interest in having regulators be part of the activity. So that provided the opening for us not only to provide data, but to actually be active in the process. A lot of the interest was around pests and pest interceptions and what the risks are associated with trade in live plants. And I think there's an assumption that the risks are primarily associated with the legitimate trade in live plants. And that's so one of the important perspectives we were able to provide was to understand that we're regulating the legitimate trade in live plants in order to avoid as much illegitimate trade as possible.
There's a whole bunch of different projects that came out of this, and each have informed policy in some different ways. But I think one very good example relates to a shift that APHIS was beginning and considering at the start of our group to a risk-based inspection system, which is a big shift in how they do inspections at the border. All live plants that are imported go through a plant inspection station run by APHIS. Historically, there is essentially a rule of thumb: inspect about 2% of every shipment that comes in.
2% of a particular shipment would be taken out, inspected by an inspector, and if they found a pest, they might take action on the shipment. If they didn't find a pest, they would release it. Even though it sounds fair and correct to do 2%, that would give you consistent data, the problem is that the probability of detection of a pest changes with the size of the shipment. So a small shipment you would under-inspect, and a large shipment you would over-inspect. The data that was coming from that was not helping us to understand where the risks really are and where we need to focus our resources.
This data collection aspect of inspection is something that we've realized is really perhaps the most valuable aspect of inspection.
We're able to develop a model and show how shifting from a 2% policy to a risk-based policy could greatly improve because of the incentives.
We're talking about an inspection design that is focused on a particular level of detection and then designing the sampling associated with that inspection to deliver that level of probability for detection. Then we have different levels of sampling for different size shipments, and the data that comes out of that is consistent. We still have the effect of deterrence because we're doing inspections, but we're getting data from those inspections now that help us to understand where the real risks are, and then we can adjust our inspections, risk-based inspections, to focus more inspection resources on the higher risk and spend less time on the things that are lower risk, where we didn't know what those things were before.
In the economic model that we used, we found that using the exact same inspection resources, you could have a 20% reduction in the number of infested shipments that would be accepted into the United States. It shows the potential gains from a shift in policy without any increase in the actual resources used at those inspection stations.
This approach to risk-based sampling is something that's being adopted in the United States and other parts of the world and should make inspection in general much more valuable practice.
This kind of partnership, that having government policymakers working with scientists, is something that needs to be reinforced. The scientists can provide a lot of help to policymakers in terms of new ideas, in terms of analytical methodologies, recommendations that are well supported in science. But also the regulators can provide the scientific community with good insights into where they can focus to really make a difference and how they can help us. And I think the more interaction of this type that we have, the better it is for both sides.